Right, so last transformation we're going to look at is called a period change. So we looked at shifting up and down. That was one of them. Shifting left and right was another one. Stretching up and down. And now, period change is when we stretch or compress left and right. Now, on Monday, we talked about the graph. And we talked about the distance from here to here. And it's been the same in every problem we've done all week. How far is it to travel through one cycle? And this is measured, you can either say it in degrees or radians. Yadio?
5.
How far?
5 minutes.
Well, a lot of times that's how many tick marks there are, but remember each tick mark doesn't represent one. Yep.
2 pi?
2 pi. Each tick mark really represents 90. So this is 90 degrees is a quarter, 180 is halfway, 270 is 3/4, and 360, or 2 pi, is the full length. All right. So now what we're going to do today is we're going to take that period and either stretch it or compress it, right? And we'll hear what that sounds like as a sound as well. All right, when we did stretching vertically yesterday, what arithmetic did we use to do that? Was that where we added or subtracted to stretch it, or did we multiply? Yep.
Multiply.
Yep, we multiplied. All right, so period change, again, that's going to be stretching or compressing, so it's going to be a multiply. With a vertical stretch, we multiplied in front. Right? So we had something like this. We multiplied out in front of the function. Today, what we're going to do is we're going to multiply inside the function, inside the parentheses, right next to the x. This is going to cause a stretch or compression horizontally. Right, in our book, just to represent a generic stretch or compression, you could really use any letter. They use the Greek letter. That's the Greek letter omega. But it doesn't matter what letter you use. The point is it stands for a number that you would plug in. So, in a real problem, in place of omega, you might have a 4. That's multiplication, and it's inside the parentheses. So that's going to cause a stretch, and it's going to be a horizontal one. Cosine 2x. Another period change. And here's one more. Sine 1/2 x. Now, we have to figure out when it stretches versus compresses. Look at the first one, sine 4x. Do you think that's going to take the sine function and stretch it 4 times as big, or compress it 4 times as small? Which way do you think it's going to be? Yep.
Stretch.
So you think it'll take maybe something that looks like this, and it would stretch it out so it looks more, I guess I can't stretch it, but I was going to try to stretch it horizontally. So you think it's going to stretch it? Okay. Let me see if I can do it with this. Yeah, so stretching horizontally would do something like that. Like it would stretch it horizontally. I don't know why I couldn't stretch that one. All right. Well, let's try it. Let's take sine of x, we'll graph it, and then we'll graph sine 4x. All right, so here's sine x. Here's sine 4x. So you're going to see the original in blue, and then in red, you'll see the new one. So what happened? Did it stretch or did it compress? Yeah? It compressed. Right? It compressed. In fact, it compressed 4 times as much. And I can show you. Just take it, put it here. And if you look at the original graph in blue, it starts at that green line, and it ends at that green line. Between those green lines, you have 1 full cycle of the graph in blue. Count how many of the red cycles you have. 4. Yeah, you have 4. There's 1, there's 2, 3, 4. So now you have 4 times as many cycles in the same space as before. So you compressed it by a factor of 4. This one would compress as well. Okay, not as much, but it would compress it by a factor of 2. And what do you think 1/2 would do?
Stretch it.
It's going to stretch it. And it's going to stretch it out twice as much. So it's going to make the graph twice as long. So with a period change, we are stretching and compressing along the x-axis. So let's go back to that graph I just put up, and let's look at 2 points and see what's changing. Is it the x value that's going to change, or is it the y value? So I'm going to go back to that other graph for a second. Let me erase what I did here, and let's pick 2 corresponding points. So that point is the end of the first red cycle, right here. So it's the end of the first red cycle. And this point is the end of the first blue cycle. This is the point before you transformed it. This is the point after, because you squished it. So if you think of this point as a coordinate, what part of the point is changing? The x value or the y value? Yep. Yeah, the x value. These 2 points are at the same height. They didn't move up and down. When you squish something horizontally, all it does is move left or right. Stretch or compress. So today, the x value is going to change. How it's going to change depends on what number you put in front. If the number you put in front is bigger than 1, like 4 and 2, those are both bigger than 1, that is going to cause the graph to compress. The bigger the number, the more compression you get. So if you put in like 10, it's going to compress it 10 times as much. If you put in 50, it would compress it 50 times as much. Now, we have looked at putting negative numbers when we multiply. We're not going to look at negative numbers today with multiplying. We're just going to stick with positives. So your number is either going to be bigger than 1, or it's going to be between 0 and 1. A number between 0 and 1 causes a stretch. Right? So it's the opposite of what you would think. It's kind of like phase shift. The bigger the number, the smaller the graph gets, the more compressed it gets. So when you make, or if you make a reference sheet, I would put that on there so you make sure you know what's happening. All right, so let's take a second and just kind of play around with a few different sounds. Thanks. So, as we said before, when you're stretching and compressing horizontally, you're changing the period. So one thing we're going to want to be able to figure out is, okay, you compressed it, what is the new period? Right? So if this is your wave, and let's see if I can compress it. Yep, now I can. So let's say that's your normal wave, and then you go like this and compress it. Well, how wide is the wave now? How much of a compression did you do? And there's a formula to figure out what the new period is, whether you stretch or compress it, whether it gets bigger or smaller. And that is the formula. So to find out the new length of one cycle, if you perform a stretch or a compression, you take the original cycle length, that's where the 2 pi comes from, and you divide that by omega. Now remember, omega is just the number, if I go back here, it's the number that's in front of x. Okay, so in this case it's 2. So what you do is you take and fill in a 2 in the bottom. Right? And then if you can reduce it, you reduce it, but you don't have to round it off to a decimal. Right, so this is similar to me asking you like what the amplitude is, because you don't have to graph it, but you have to know what number you're looking at in the equation. And you're looking at the one that's right in front of the x, and that goes in the bottom of the fraction. Right. So let's try an example. Right, let's find the period of sine 2x. So yada yada, what's in place of omega in this problem? 2. So you're going to take 2 and you're going to fill it in. Okay? This is the number you're looking at, 2. So the new period is 2 pi. The top always stays the same. That never changes. Okay? It's always 2 pi. It's the bottom that changes. And in this case, it's a 2. And when we reduce that, what do you get? Yep. Pi. So what that means is the original cycle length was 2 pi. Now the cycle length is 1 pi. You compressed it. You made it smaller. You shortened the amount of time that it takes to do one full cycle. And you shortened it by a factor of 2. Okay. All right, let's try this one. Cosine 5x. So, Annika, if I want to find the period of this one, what would go in the top of my fraction? 2 pi. And what would go in the bottom? 5. So the original cycle was 2 pi, and you've taken the original cycle and you've divided it by 5. That means you compressed it. You made it 5 times smaller. And this time, there's nothing to reduce, so we just leave it just like that. So what this is telling you is if this was your graph, it's starting at 0, and now it's ending at 2 pi over 5. This is the length of one full cycle. So once you travel 2 pi over 5 units, from there to there, you've reached the end of your cycle. Okay. With this one up here, if you had your graph, what it's telling you is it starts at 0. It always starts at 0. And you have to travel pi units to finish the cycle. So this is a quarter of the way, halfway, 3/4, all the way. So now instead of ending at 2 pi, it ends at 1 pi. Actually, that's a cosine graph, and I did sine, but that's okay. I just wanted to show you the idea. Yeah.
Will there ever be a problem where we have to find the period length and then like do a phase shift or something? Or is that just like
No, we're not doing problems that have multiple transformations.
Okay.
So you're not going to have to like shift it up and then do a period change. You'd have one problem on the test that would be shift up, and a separate problem on the test that's a period change. So no multi-transformations. All right, let's look at this one. Sine 1/4 x. All right, Andrew, when I want to find period, what would go in the top?
2 pi.
2 pi. And I'm just going to make it a fraction this time. So I'll put it as 2 pi over 1. And Matt, what would go in the bottom?
4 or
1/4. Yep. So you always put that number in the bottom. Now this is why I made the top a fraction. Because when you divide two fractions, can someone remind me how you do that? Yep.
Wait, common denominator.
That's when you're adding or subtracting. So you don't need a common denominator to divide. But you do for adding and subtracting, and we did that on Monday.
How do you multiply that by the 0?
Yeah, you keep the top the same, and you multiply by the reciprocal of the bottom. What is the reciprocal of 1 over 4?
4 over 1.
4 over 1. And if I multiply 2 pi by 4 over 1, what do I get? 8 pi. How does 8 pi compare to 2 pi? It's a stretch, right? It's a stretch by a factor of 4. And that's exactly what should happen. When you put a small number in front of x, it causes the graph to get bigger. A question on that? Now, what if I did this? What would be the period now with that plus 3 on the end? Yep.
8 pi.
Still 8 pi. All you did is you just took what you had and you moved it up 3. Well, I don't care where you move it, it still has the same period. How about if I do that? Let's do a different number. 8. What would be the period of that one? Doug?
It'd still be 8 pi.
It would still be 8 pi. The only number that affects the period is the number that you put right there. These numbers do other things, like a shift up 3 or a vertical stretch by a factor of 8. So this changes your amplitude, but that's the only number that changes the period. So you will have ones like this on the test. You won't have to graph this, because I just told you you wouldn't be graphing a multi-step one, but I might ask you to identify something, like what's the amplitude or what's the period. Questions on that? Okay. So, stretching and compressing horizontally means x's are going to change. The y values do not. Unfortunately, the y values are the easy ones to work with, and we don't get to work with those today. So your y values for sine, 0, 1, 0, negative 1, 0. And for cosine, 1, 0, negative 1, 0, 1. All right. Now, how do we find the new x values? Well, let me draw one more sketch, and then I'll show you how we're going to do that. So the idea here is everything is stretching and compressing horizontally. Here is a graph. Watch what happens. Hopefully I can do it. Yeah, perfect. Okay. Watch what happens if I compress it horizontally. I want you to focus on this point right here. If I compress it, did this point move on the left? How about if I stretch it? Did that point on the left move? No. What's the x value of this point? Right there. Yes?
0.
It's 0. And no matter how you stretch or compress the graph, that point never changes. Because think about if you take 0 and you compress it. Well, if you compress 0, 0 is always 0. If you take 0 and stretch it by multiplying 0 by a number, it's still 0. So stretching and compressing the first x value doesn't change it at all. So the first x value is always 0. So the first x coordinate is always 0. Now, the next one we're going to look at is the fifth x coordinate. How can I figure out where this one is? How do we figure out the length to travel one full cycle? What do we use? Yep.
Y equals either sin or cos over 2 pi over omega?
Yeah, we use the 2 pi over the omega. That formula will tell you the distance to travel one cycle. So to get the beginning, it's always 0. To get the end, you take 2 pi and divide by omega. And that tells you where your fifth x coordinate is. Okay, I'm thinking the first one is the beginning, the fifth one is at the end. Now remember, all these coordinates are equally spaced. That's how we've done all the graphs all week. We always pick points that are nicely spaced. So if you know where the beginning is, and you know where the end is, how do you think you could find the point that's in the middle? Yes, yeah? So, yes, trying to think of an even easier way to explain that, but yes. Think about, you got a point here and a point here, and you want the one here.
Just half.
Yeah, half of it. That's one way to think of it. Or you can also think like if you had a grade here and a grade here, and you want the one in the middle. Yeah.
Midpoint point.
Yeah, it's like the midpoint. It's the average. It's the average of the two. Yep. Which, when you average something with 0, yes, it's always half. Like if you got 100 and you've got a 0, and now you have a 50. To average with 0, you just take half of it. But I think an even easier way to think about it is just say average. So the third x coordinate is the average of the beginning and the end. That's why you have to find the beginning and the end first. So there's your third x coordinate. Now we'll go back to that graph and let's see if we can find the second x coordinate. And it's going to be on the same idea as what we just did. Here's your second x coordinate. How do you think you could find the second one if you know the first one and the third one? Yeah? Yeah, which two would you average?
The starting and the middle.
Yeah. The first and which one?
The
The middle. Yeah. If you average the first one and the third one, you'll get the second one. So the second x coordinate is the average of the first and the third. And then the last one we need is the fourth. Let me just draw it again. So we get the beginning, the end, the middle, the second. How do you think we would get the fourth x coordinate, given that it's equally spaced with everything else? Yeah?
Average of the third and the fifth one.
Yeah, average the third and the fifth. So the fourth x coordinate is the average of the third and the fifth. Now I just want to make sure everyone knows what we mean by average. We're always going to be averaging two things. Can someone explain to me in general, how do you average two things? You have to, it's actually two steps. Yeah.
And then divide by 2.
Yeah, if you want to average two things, you add them and divide by 2. So Yadiel mentioned something about common denominator. That might come up. Okay, if we have to add fractions, they need to have common denominator. So yes, add them and divide by 2. That's perfect. What's another way of dividing something by 2? Thinking of multiplication. Multiplying by this is exactly the same as dividing by 2. Yep?
Multiplying by 1/2.
Yeah. So I think when we write it out, I'm going to multiply by 1/2 just because it's going to visually look simpler. But yeah, dividing by 2 is the same thing. All right. So now that's how you find all your x coordinates. The first and the fifth you do first, then you do the third, and then from there you could do the second or the fourth. You could do them in either order. Okay, so let's try this one. All right, so now that we know all the different transformations, they're all going to be mixed up on the test. They're not necessarily going to be in the order that we learned them. So the first step is to recognize what kind of transformation this is. So the first thing you should do is identify what type of arithmetic are we doing here. Are we adding, are we subtracting, or are we multiplying? Those are really the three things we've done this week. Matt? Yep. Again, we're multiplying. Okay, so multiplying tells me something. Anytime you multiply, that is a stretch or compression. But I don't know yet if it's a vertical or a horizontal. So the next question, where are we multiplying? Is it next to the x, or is it in front of the function?
Next to that.
It's right next to the x. If you put parentheses, we could say that it's inside the parentheses. Anything inside this box is horizontal. What you do inside that box controls whether it's a shift or a stretch. Adding and subtracting would be a horizontal shift. Multiplying makes it a horizontal stretch. So anything inside the box is a horizontal. Anything outside the box is a vertical. Adding and subtracting is always a shift. So add or subtract is always a shift. Inside the box, horizontal. Outside the box is a vertical. Multiply is a stretch or a compression. So that pretty much summarizes everything we've done this week. All right, so this is a horizontal stretch or compression. So when we stretch and compress horizontally, what values do not change? Which values are going to stay exactly the same? Yeah? The y's. When you stretch something horizontal, it moves left and right. It does not move up and down. So let's keep our y's the same. And can someone remind me, what are my y values for sine? Yeah, Julia?
0, 1, 0, -1, 0.
0. Perfect. Okay, so we've got our y values. Now let's make a box where we're going to put our answers. Off to the side of the box. Well, actually, we don't even need to do it off to the side right now. The first x coordinate is always what number? You don't even have to think about it.
0.
It's always 0. And I tried to show you that by stretching and compressing and showed you that point stayed still. It didn't move. So we've got the beginning. What's the next coordinate that we find? We got the first one. We need which one next? Yep.
Fifth one.
Yeah, we need the fifth one. And do you remember what the formula is? Yadi, find the fifth one.
T equals 2 pi over omega.
Yeah. So it's t equals 2 pi over omega. And Tyler, what's omega in this case?
2.
2. So it's 2 pi divided by 2, which comes out to pi. So now I know where my graph starts and stops. Now I want to find the middle. Okay, so remember how we find the middle. We add them up and divide by 2. Or add them up and take 1/2 of it. Yep.
Maybe pi over 2 then.
Yeah, it's going to be pi over 2. Because really, you're averaging something with 0. Anytime you want to average with a 0, just take half of it. That'll average something with a 0. So this is pi over 2. And now, we're going to average again to get the one that's in here. But you're averaging with 0. So what's halfway between 0 and pi over 2?
Pi over 4.
Pi over 4. If you did this in degrees, this is 0. This is 90. That's 45. It's exactly halfway between. Now the third one might, or the fourth one might be a little tricky. So let's do that the way I explained. Let's average them, but you're not averaging with a 0, so you actually have to do it up. So we're going to take pi over 2. We're going to add pi. So you have to add them up, but then you have to take half, because that's how you average. Okay, what's wrong with trying to add these up the way they are? Yep,
They don't have the common denominator.
don't have a common denominator. Can you tell me what my common denominator would be?
2.
Yep, common denominator of 2. The one on the left already has a 2, so I don't have to change it. What would you multiply the fraction on the right by?
2.
2. 2 in the bottom and 2 in the top. Bless you.
Thanks.
So now we've got this. What's pi over 2 plus 2 pi over 2? That becomes 3 pi over 2. Remember, you keep the denominator the same. You just add the numerators. And now when you multiply fractions, you go straight across. So what's half of 3 pi over 2? Yep, 3 pi over 4. And I told you there's always a pattern in the x's. You might not see the pattern here because not everything has a denominator of 4. But if I wrote every one of these x values with a denominator of 4, look what you'd have. 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. But we've reduced it so you don't see that pattern. But that is the pattern. Okay, so there's your x values. Questions on the table? All right, so now let's do our sketch. So today, the y values are always going to be as high as 1 and as low as -1. You're not going to have to adjust that. What you do have to adjust is your x values. Now, these x values are all equally spaced. How do we know that? Because we found them by averaging. Whenever you average something, it always gives you what's exactly in the middle. Since these are equally spaced, use them as your labels for your graph. Because that's the only condition when you label an axis. You have to use equally spaced numbers, like 2, 4, 6, 8. Let's use those labels. So this would be 0, pi over 4, pi over 2, 3 pi over 4, and pi. Right, and now plot your points. So you got 0, 1, 0, -1, 0. 0, 1, 0, -1, back to 0. And there's your sketch. Now, my graphs are not going to look stretched or compressed because I'm changing my scale. Just like we changed the scale when we did vertical stretch. If you change the scale, you can't really see the stretch. But by doing it this way, if I stretch something really big, it's not like I'm going to have to draw it really big. Just change my scale. Okay. Questions on that? All right, so let's take a look at this one. Cosine 1/4 x. So I've gone through it a bunch of times. Can somebody tell me what are the 2 things that you look for that tells you what kind of transformation this is? Yep.
If it's inside the parentheses, not going to be horizontal.
Yep. Something's happening inside the parentheses, so it's definitely horizontal. Now we need to be more specific about something. Can somebody tell me exactly what's happening inside? So we're trying to think about it like arithmetic. What are you doing? What math arithmetic are you doing? Multiplication. Multiplication is always a stretch or compression. But it's a stretch or compression. And as Desiree said, it's inside the parentheses, so that makes it horizontal. Okay, so what values do not change when we do a horizontal stretch or compression?
1.
Yep, the y's. And can somebody tell me my y values for cosine? This is where you don't want to mix them up with sine. Yep.
Is it 1, 0, negative 1, 0, 1?
Yes. Perfect. So again, I know I've said it a few times, but that's going to be worth 10 points. Those 5 values right there would be worth 5. Okay, x's. When we do a stretch or a compression, the first x value is always what number? 0. That doesn't change. Now we need to figure out the ending x value. Well, we have a 1/4 in front. We've already done this. We did it right here. When we had a 1/4 in front of the x, what did we get for the length of the period? 8 pi. This tells me where the graph ends. So the last point in this cycle is 8 pi radians. So 8 pi. Any question how to do the 2 pi over 1/4 again to get 8 pi? Because this is exactly what you would do in this problem. Okay, so that's 8 pi. And now, we need the third point, which is halfway between. What's exactly halfway between 0 pi and 8 pi? 4 pi. And now I need what's exactly halfway between again? 2 pi. And I need halfway between again? 6 pi. Because there's no fractions this time, I think the pattern is very easy to see. 2, 4, 6, 8. So the numerator, the coefficient is just even numbers. And that's it. So you didn't have to worry about finding the common denominator because the averaging was a lot easier this time. Sometimes it's a little harder like it was in the last problem. Sometimes it's easier like it is in this problem. Okay, questions on the table? All right. So let's set up our graph. Let's take this and make this so you can see it a little better. Okay. The highest y value is 1, lowest is negative 1, and these are all equally spaced. So you use them as your labels. 0, 2 pi, 4 pi, 6 pi, 8 pi. All right, so 0, 1. 2 pi, we're at 0. 4 pi, you're at negative 1. 6 pi, 0. And 8 pi, back to 1. Now, it doesn't look stretched. It looks the same size graph that I've been drawing all week. Why doesn't it look stretched? It should have stretched it 4 times as big. Yeah.
So we changed the values.
Yep, we changed the scale here. Right? We changed the scale. If you don't change the scale, then you're going to need something 4 times as big to draw it. So it's easier to change the scale. Okay, questions on that one? All right, so last one. Y equals sine of pi over 2x. All right, so first question. Where am I doing something in this problem? And by now you should know the 2 options.
The horizontal.
Yep. Good, Connor? In the parentheses. So in the parentheses means we are doing something horizontal. Now, what type of arithmetic are we doing inside? Adding, subtracting? That's one thing. Or are we multiplying? Yep. We're multiplying. Multiplying is always a stretch or compression. And we just said it was inside parentheses, which means it's horizontal. Even if you didn't put parentheses there. Okay, then don't say inside the parentheses, then just say right next to the x. Same thing. It's right next to the x. Okay. All right, let's make our chart. We know y values are going to be the same. TJ, can you tell me what my y values are for sine?
0, 1, 0, negative 1, 0.
Okay, so we got those. How about Ryan? When I do a period change, my first x value is always
0.
0. Okay, so we got that one. We got 6 of them. Now, what's the formula to figure out where the cycle ends? Yeah.
2 pi over omega.
2 pi, which if you want to make 2 pi a fraction, you can. I only make the numerator a fraction when I know the denominator is also going to be a fraction. So there's 2 pi over, what's omega in this case? Yeah?
Pi over 2.
Pi over 2. And I know we did it earlier, but can someone just remind me again, how do you divide a fraction by a fraction?
Reciprocal.
Take the top and multiply it by the reciprocal of the bottom. What is the reciprocal of the bottom? 2 over pi. What happens when I multiply those together? Yeah?
The pi cancels.
Pi cancels. Because you have a pi in the top, pi in the bottom, just like when we convert between like degrees and radians. Same idea. And what are you left with? TJ? 4. So this graph ends at 4. This is the first time all week we're going to have x values that don't have pi in them. And that's because the pi canceled out. That's the way the problem worked out. So now, what's my third x coordinate? 2. My second x coordinate? And this one? 3. So those are your x values. Now, technically, if you don't label your axes, what number do we always assume you're going by if you don't put labels? 1s. And you could leave labels off this problem and it would be right, because we are going to go by 1s. I'll put them in just because we're used to doing it. But this is the only problem this week that you could not put labels anywhere and it would still be right. This is 1, -1. And graphic points. 0, 0, 1, 1, 2, 0, 3, -1, 4, 0. And there's your graph. Any questions on that? All right, so that is period change. Okay, so tomorrow, the plan will be we're going to review, we'll go over the homework, and then there's a review worksheet online to practice for the test tomorrow. Okay, I'll put a list of topics in this video right now because this is the last video for the week. That's where I usually put the test review. So, test topics. Remember, test isn't till Friday. So you have to know how to make a table for all the transformations we've done. Phase shift, that was Monday. A vertical shift, that was Tuesday. An amplitude change, that was also Tuesday. And a period change.
What's the third one?
Amplitude change, or vertical stretch. So you have to know how to make the table. What else? Find the amplitude or the period given an equation. Right, so that's where you use the formula 2 pi over omega to find the period. Or if you're finding the amplitude, that's where you take the absolute value of the number in front. And the last thing would be, you know what, I'm just going to add it right here. How to make a table and graph those. Now, I'll write it separate. So graph 4 transformations above. So that's everything that's on the test. Making tables, graphing, and finding amplitude and period. Also, probably the only test you really won't need a calculator for, because you're not writing decimals or anything. And the arithmetic, really, if you use a calculator, it's just going to mess you up because it's going to give you decimals. So I don't think you'll really need a calculator. So homework tonight is a worksheet. It's in the same place that the last 2 were on Schoology. Does anyone have a question on where to find the worksheet? So I'll check that tomorrow, and then we'll review for the test on Friday.